Hi, welcome to another session of Circuits and Networks. In today's transient analysis class, that is in class 10, we are going to see some problems involved with RC circuits, especially in the name of transient current and transient voltage. So here you can see there are two different examples where in example 1 you can see 10 volts is connected to passive elements and the switching position is changed from A to B. Then we need to find out the transient current and transient voltage. Whereas in this problem, if at all the capacitor is already charged with some voltage, then how to obtain the transient current is our main concern. So not only these two problems, we are going to see two more problems in order to understand the behavior of RC circuit in transient analysis. So what we should keep in our mind before solving with RC circuit, especially dealing with transient analysis, we should know that the voltage developed in the capacitor, it is nothing but given by Vc is equal to 1 by C integral IDT plus V initial of zero conditions. Means what? Whatever the voltage is stored in the capacitor initially, that voltage we are treating as V initial voltage. So that representation is V initial of 0. So if at all we have 0 voltage as the initial conditions of capacitor, then the voltage across capacitor is given by 1 by C integral IDT. So this is very important formula that we need to concentrate. And if at all we need to know the current through the capacitor, then it can be obtained with the help of this equation by differentiating on both sides. We are going to get IC is equal to C dV by dt. So these are the formulas which you should concentrate before dealing with capacitor circuit, especially in the case of transient analysis. I hope you remember these two formulas and we'll see how these two formulas are going to give their importance in transient behavior. Okay, so in the first problem, the switch is closed at t equal to 0. Means what? The 60 volts which is supplying to these passive elements under this figure 1, okay, it is open. So no current will flow into the circuit. And we need to find out the current through 40 ohms at t equal to 0 plus condition. Means what? As soon as switch is closed, and transient voltage, which is nothing but the voltage across capacitor. Here the capacitor value is 10 millifarads for t greater than 0 are respectively. Here we have four options. Especially we are going to see this kind of options in the competitive exams, like in gate exams or any competitive exams, like central government jobs or state government jobs. They are going to ask the questions in this pattern. So what is the beauty of this problem? We should know that the value of current, it is 1.5 amperes and that is fixed. So here in this problem we are going to check whether we are getting the same value of current or not, because in all the options ABCDs the current is the same, only the transient voltage is different. We'll see how we are going to obtain the value of voltage for t greater than 0. So let us solve the problem. So from the given conditions at t equal to 0 minus, the circuit is open. Naturally the circuit is open because no current is flowing, and there is no development of voltage across passive elements because current is not flowing. So what we can say, the voltage across capacitor is 0 volts since the current through the capacitor is 0 amperes. Since the switch was open for a long duration of time and no supply is given to the passive elements, that's why the voltage developed across these passive elements is 0. So that is what it is mentioned by these two values. The VC of 0 minus is 0 volts, IC of 0 minus is also 0 amperes. Now what happens as soon as the switch is closed? As soon as the switch is closed, the capacitor, with the transient analysis in the previous classes we have seen, it will be behaving as short circuit. So as soon as the switch is closed, the capacitor behaves as short circuit. If the short circuit is applied, naturally the circuit is closed all the way. You can see all the parameters are connected to 60 volts. And we need to find out what is this I of 0 plus. Because the circuit is closed, naturally the current will flow. So what is that instant value of current which is flowing through the capacitor? Now you give a clear observation that 60 volts is connected to 20 ohms. Means what? 60 is parallel with 20 ohms. So naturally, the voltage in 20 ohms is 60 volts. Now this 60 volts, which is parallel to 20 ohms, is in series with 40 ohms. Hence, I'll apply KVL, that is algebraic sum of the voltages in a closed circuit is equal to 0. So it will be minus 60 plus 40, I of 0 plus is equal to 0. With this, I am going to get the value of current, which is nothing but I of 0 plus is equal to 60 by 40, that is 3 by 2, which is 1.5 amperes. Thus, satisfying all the options which are given in the problem. So 1.5 amperes is the value of current in 40 ohms at t equal to 0 plus. Also note that Vc of 0 plus is 0 volts. Why this is 0 volts? Because capacitor voltage cannot change instantaneously. So before switching, the value of voltage is 0. So immediately after switching also the value of voltage will be 0 volts, especially in this particular problem. So this we have to keep in our mind. So I'm treating this as equation 1. And already we have done with 1.5 amperes, which is satisfying all the four options of the given problem. Now, when capacitor is connected to 60 volts, means what? The switch is closed. Okay. Now, after t is equal to 0 plus, okay, when we are starting with the analysis of the capacitance got connected to the rest of the elements, that is 20 ohms and 40 ohms, with the input voltage as 60 volts. With this, we need to find out the transient voltage across capacitor, whose value is 10 millifarads. So this is the voltage we need to find out over here. Now you observe carefully what we have seen. 60 volts is applied to 20 ohms and 60 volts is connected to 40 ohms in series. In fact, the same circuit is connected in series with 10 millifarads, and I need to know the value of voltage across 10 millifarads. So at this particular point, I am treating as one node, and with this I am going to apply KCL. What is the KCL? Algebraic sum of the currents at a particular node is equal to 0. So what is the current which is flowing on the left side of the circuit? You have 60 volts, you have 40 ohms, and you have VC over here. So the unknown voltage is VC, the known voltage is 60, and that known voltage and the unknown voltage got divided by 40. So this becomes one branch current, and the current through the capacitor. The current through the capacitor, we have already seen from the basics that it should be capacitor multiplied with differentiation of voltage. So the current which is at this particular node, which is flowing through 40 ohms, is nothing but VC minus 60 by 40. This is one branch current plus C dV by dt. C is 10 millifarads. dVc by dt. This is the unknown voltage. So we have seen the formula for current, which is nothing but C dV by dt, and that is replaced by 10 millifarads dVc by dt equal to 0. This we are treating as equation 3. Now I am going to simplify this equation 3. I am going to take this 10 millifarads dVc by dt as 10 into 10 to the power of minus 3 dVc by dt plus you have Vc here, Vc by 40, and you can see you have 60 by 40 also. So which is equal to 60 by 40. So in this equation 3, we are taking the constant term on the right hand side. Is this clear? Just simplify this equation. So I'm going to get dVc by dt plus this 10 milli is taken to the denominator of Vc. It becomes 40 into 10 milli value. So milli will go to the numerator, it becomes kilo. So that is how we got here 1000 Vc by 400. Similarly, 60 divided by 40 changes to 60,000 divided by 400. So further we can simplify this equation and it becomes dVc by dt plus 2.5 Vc is equal to 150. Now this is a kind of non-homogeneous equation. So this we're treating as equation 4. And for non-homogeneous equation, that is dV by dt plus Vv is equal to Q. The solution is V of t is equal to e to the power of minus pt integral Q e to the power of pt dt plus k e to the power of minus pt. Now this equation is a general solution for non-homogeneous equation which is in this form. So equation 4 can get a solution in terms of V of t, as V of t is equal to e to the power of minus 2.5t because p is 2.5 integral q. From equation 4, q is 150 multiplied with e to the power of pt, p is 2.5t dt plus k e to the power of minus 2.5t, and this we're treating as equation 5. I hope you understood how we frame equation 5 from non-homogeneous equation 4. Now for the solution we have to simplify equation 5. You can see 150 I can take outside, and integration of e to the power of 2.5t is e to the power of 2.5t divided by 2.5. So this is a normal integration. You can look into the basics. So on the outside we have e to the power of minus 2.5t, and integration of e to the power of 2.5t is e to the power of 2.5t. Both will cancel out, but in denominator we'll be having 2.5, and already 150 is outside. So 150 divided by 2.5 plus k times e to the power of minus 2.5t. So this is the solution for equation 4. Now we can determine easily the value of k. K can be determined from initial conditions. So this 150 by 2.5 gives you the value as 60 plus the constant in terms of e to the power of minus 2.5t. So equation 5, we don't know the value of k. Sorry, equation 6, we don't know the value of k. So k can be obtained from initial condition at t equal to 0 plus. We know that the V of 0 plus is 0 volts. So I'm substituting here V of 0 as 0, which is equal to 60 as it is, plus k e to the power of minus 2.5 times 0. So e to the power of minus 2.5 times 0 becomes 1. Hence the value of k will be equal to minus 60. Let us take this k value and substitute in equation 6. So what I'm going to get? I'm going to get V of t, which is equal to 60. Already 60 is there. K value is minus 60. So minus 60 to the power of minus 2.5t. So I'm taking 60 outside and becomes 1 minus e to the power of minus 2.5t volts. So hence in our options, what you can see, 60, 1 minus e to the power of minus 2.5t volts. C is the answer. Is this clear? How we got C option? So answer is C. So this you take as the answer. So we have solved this problem and we got the result as 60 of 1 minus e to the power of minus 2.5t volts. I hope you understood this problem. Now we got the V of t for t greater than 0. Let us switch on to the next problem. In figure 2, the switch is moved from position A to position B at t equal to 0. Means what? Initially the switching position was at A and the steady state conditions have reached. That is also mentioned here. So before switching, the steady state conditions have reached. What is our interest? We need to find out the transient current through 4 ohms and transient voltage, that is given by V4 of t for t greater than 0. So these are the unknown values we need to find out. So we need to find out the transient current as well as the transient voltage. Okay. So let us stick to the basics first. So what is the information given? That switch is positioned at A. The switch is positioned at A and the steady state conditions have reached. When the steady state conditions have reached, the capacitor behaves as open circuit. Initially the capacitor will behave as short circuit, but under transient conditions for long duration of time, it behaves as open circuit. So as long as the switch was at position A and 10 volts was supplied to the 0.02 farads, it has received the entire voltage to itself and the circuit got open, and this is how the circuit will become from figure 1 to figure, from figure 2 to figure 2a. This 4 will remain as it is, and we need to find out the voltage across the capacitor and the voltage across 4 ohms when current I of 0 is flowing before switching. Okay, since the open circuit, the current is 0. Naturally, when open is done with the circuit, current will not flow. So that is why current value is 0. So this is an important factor for the behavior of the capacitor. Since capacitance has open circuited, there is no current in the passive elements. So hence, when current is not flowing through the circuit, naturally there is no voltage developed in 4 ohms. So that is why V4 of 0 minus is also 0 volts. Since open circuit, no current will flow, and no current will flow, naturally no voltage will be developed across resistance. But remember, capacitor got charged. Capacitor got charged to the supply, 10 volts. So hence, V of 0 minus will be equal to 10 volts. So this we are treating as equation 1. All these values are treating as equation 1. I hope you understood this particular concept, especially the behavior of capacitor. Right. Now, as soon as the position of the switch is moved from A to B, 8 ohms is getting connected and capacitor is already charged to 10 volts. And hence we can find out the value of current in 4 ohms. So for T is equal to 0 plus, as soon as the switch is moved, and if at all I apply KVL to this loop, I'm going to get 8 of I of 0 plus 10, that is the voltage, plus 4 I of 0 plus is equal to 0. With this 8 plus 4, 12 I of 0 plus is equal to, this 10 goes to this side, becomes minus 10. Hence the value of I of 0 plus will be equivalent to minus 0.833 amperes. And once I got the value of voltage through 4 ohms, sorry, once I got the value of current through 4 ohms, I can get the value of voltage through 4 ohms by multiplying resistance with current. So minus 0.833 multiplied with 4, I'm going to get the value as minus 3.33 volts. It's a very crucial step and important step you need to understand. The switch position is moved from A to B and capacitor is charged with 10 volts. Now the charged voltage is connected to 8 ohms and 4 ohms and the circuit is closed. The charge voltage is connected to 8 ohms, 4 ohms and the circuit is closed. Hence the current will flow, and this is how the current developed through 4 ohms, and once the current is developed, voltage will be developed across 4 ohms in this fashion, which is our requirement. Clear? Now for t greater than 0, actually the capacitor is charged with voltage 10 volts. So this is the main circuit, and you can see this is the same circuit which we have seen in the beginning of the class. Now this is the capacitor which is charged with 10 volts, and we need to find out the voltage across 4 ohms, that is the transient voltage. Now this is different from first two equations, equation 2 and equation 1. It is different because those are the values of the amplitudes or constants. Now here we are going to get the transient current and voltage. Let us see how. So I'm going to apply KVL to this circuit 2C or figure 2C. So this is 8, so that's why 8 into I plus the voltage developed in capacitor. So already we have 10 volts and the voltage across capacitor is given by 1 by C integral I dt. This is from the basic formula, plus 4I equal to 0, and this I am treating as equation 3. I hope you understood how I framed this equation. See, 8 and 4 are both are resistors, that's why it is 8I and 4I. Is this clear? And capacitor voltage with initial voltage is formula is 1 by C integral I dt plus V of 0. So V of 0 already we got the value as 10. So that is why this parameter is placed and this voltage is substituted in KVL equation. Now it's a simple equation. Equation 3 is a simple equation. We can easily differentiate with respect to t. Why we need to differentiate? Because we need to know the value of tangent current and voltage. That's why I'm differentiating this equation 3. So what I'm going to get, you see here you have 8 and 4. So 8 and 4 with I and differentiation it will give you as 12 di by dt. And differentiation of integration will give you the value as I by 0.02 is equal to 0. Why 0? Because differentiation of constant is 0. That is why this equation is framed as 4. I hope you understood how we framed equation 4. Clear? Good. Now, simplifying equation 4, you can see I have di by dt plus I divided by 0.02 multiplied with 12. So 12 multiplied with 0.02 will give you one constant value, but 1 I divided by that constant value will give you the value as 4.166I equal to 0. Now, this is a homogeneous equation of this order. So di by dt plus vi equal to q. This is a homogeneous, sorry, non-homogeneous equation where when q becomes 0, when q becomes 0, so this goes to 0, it becomes a homogeneous equation. Is this clear? If q is present, means if constant is present, it becomes a non-homogeneous. And when we don't have any q, then it becomes a homogeneous equation. So for that we have solution as I of t is equal to k multiplied with e to the power of minus pt. Is this clear? Yeah. So let me erase the things for understanding. Okay. Yeah. Now the solution we are going to find out for homogeneous equation as I of t is equal to k multiplied with e to the power of minus 4.166t. Now here we need to find out the value of k. And what we have determined that k can be obtained from initial conditions. So the determination of t equal to 0 plus leads to the value of current as minus 0.833 amperes. Just substitute this value in equation 6. So I of 0 plus is equal to minus 0.833 which is equal to k multiplied with e to the power of minus 4.166 multiplied with 0. So it becomes e to the power of 0. Hence the value of k is minus 0.833. Once we obtain the value of k, substitute the value of k in equation 6. So it becomes I of t is equal to minus 0.833 e to the power of minus 4.166 t amperes. So equation 8 is very important, that is the transient current which is flowing in the circuit. Fine. Once this transient current is flowing through the circuit, what is our next level of interest? We need to find out the value of voltage in 4 ohms. So voltage in 4 ohms is given by Ohm's law. So Ohm's law states that the resistance multiplied with the current. In simpler way, the current is minus 0.833 e to the power of minus 4.116. So I'm just substituting the equation 8 in B4 of t. So which will give you the value as 4 multiplied with this value, which will be equal to minus 3.33 e to the power of minus 4.166 t volts. So this is how we solve the problem, especially with capacitor circuit. Let's give a quick check for problem 3. Now the switch is open here and it is going to get closed at t equal to 0. We need to find out Vx. Vx is across 0.4 farads. In fact, Vx is parallel to 32 ohms also. So whatever the value of voltage is across 0.4 farads will be the same voltage value across 32 ohms. Let us see how. So naturally when the switch is open, no current is flowing through the passive elements, that is true. So Vx of 0 minus is 0 volts, that is understood. At t equal to 0 plus means what? At as soon as the switch is closed, what I told, capacitor initially behaves as short circuit. So this is how the circuit will look like. Switch is closed, capacitor becomes short circuit, and Vx of 0 plus is a measurement of voltage across short circuit. In fact, Vx of 0 plus is across 32 ohms. So naturally, short value will give you the value as 0 only, because the voltage across capacitor cannot change instantaneously. That is why Vx of 0 plus is also 0 volts. Is this clear? So figure 3 changes to figure 3a in this condition. Right. Now what happens for t greater than 0? Means what? After the switching conditions, when capacitor is connected to 24 supply. So this is the practical circuit which is shown in figure 3b. Now Vx is connected. Now Vx we need to find out, which is making the 0.4 farads to get connected with the 32 ohms in parallel, and this combination is supplied through 24 volts in series with 8 ohms after switching. Okay, so Vx is parallel to zero point 0.4 farads and Vx is also parallel to 32 ohms. Hence what I'm doing, I'm going to take the common voltage at this top. So this common voltage at the top becomes Vx. Is this clear? The switch is closed, so it is taken in black. This red is changed to black. Capacitor is connected. Vx is parallel to zero point 0.4 farads and 32. So parallel value I'm taking as Vx common. Now here I'm going to apply Kirchhoff's current law. So in figure 3b, that is this figure, we are going to apply Kirchhoff's current law. That is the branch currents at a particular node is equal to 0. So what is the branch current on the left side of this circuit? Vx minus 24 by 8, agree? Then you have capacitance, so it becomes 0.4 farads dVx by dt. Is this clear? From our basic formulas, we have taken this voltage, this current developed across the capacitor, plus we have Vx by 32 equal to 0. Now this equation can be further simplified. I am taking this zero point 0.4 farads on this side, and Vx I am taking common. I have 1 by 8 and 1 by 32 and 24 by 8 on this side. Furtherly, dVx by dt I am taking here plus Vx. 1 by 8 becomes 0.125. 1 by 32 becomes 0.03125 whole divided by this zero point 0.4, because I have taken out this zero point 0.4 from dVx by dt. So divided by this Vx value, which is equal to 3, because 24 by 8 is 3, divided by zero point 0.4. I hope you understood this equation. This can be further simplified in this fashion. So dVx by dt plus 0.39 Vx is equal to 7.5. Now this is the non-homogeneous equation. So this non-homogeneous equation can be solved with the help of general solution of V of t is equal to e to the power minus pt integral q e to the power of pt dt plus k e to the power of minus pt. So I'm going to substitute wherever we have p, there I'm going to substitute the value as 0.39, and wherever I have q, there I'm going to substitute the value as 7.5. So naturally e to the power of minus 0.390 integral of e to the power of 0.390, this both will cancel, but e to the power of 0.390 integral will give you the value as the same e to the power of 0.390 divided by 0.39. So 7.5 divided by 0.39 plus k e to the power of minus 0.390. Now this can be further simplified, that is 7.5 divided by 0.39 as 19.23 plus k to the power of minus 0.390. Now k can be obtained from the initial conditions. So k can be obtained from the initial conditions. At t equal to 0 plus, we obtain the value of Vx of 0 plus is equal to 0 volts. Just substitute the value 0 equal to 19.23 plus k to the power of 0, which is 1. So k will be minus 19.23. Just substitute the value of k in this equation Vx of t. I'm going to get Vx of t is equal to 19.23 of 1 minus e to the power of 0.390. So very quickly we have solved this problem. If at all you have any doubts, please comment in the chat box. And let us go with the last problem, that is finding out the transient voltage Vc of t for t greater than 0. Now you can see the switching position, unlike the previous problems, it is set in between the circuit. Now initially the switch was open, okay, the supply is connected to capacitor through 4 ohms, and hence capacitor will develop some voltage. Now with the developed voltage, the switch will be closed, and then we have to see the transient voltage. So that is what we are going to see in this problem. So in figure 4, at t equal to 0 minus, the circuit is open. The circuit is open here, okay, but the current will flow. Why the current will flow? Because 12 volts is connected in series with 4 and in series with 0.2 farads. So current flows to the passive elements here, and when the steady state conditions are reached, capacitor acts as open circuit. That is already we have seen. So hence this figure 4 changes to circuit which is shown in figure 4a. What is that 4a? Yeah, this is the figure. So you can see the capacitor voltage has developed 12 volts, okay, because this 12 is there, and this 4 ohms becomes dummy. So whatever the voltage is there in the actual potential, that is going to be measured as same value, 12 volts. Now figure 4a can change to figure 4b once the switch is closed. Now once the switch is closed, the capacitor got as charged voltage which is 12 volts, that we need to keep in our mind. Now actually this is the circuit, but what we is the interest is finding out the capacitance voltage. So how this can be done? So as I told you, since VC is parallel, you can see the VC is parallel to 2 ohms. Though the switch is closed, this 2 ohms is parallel to 0.2 farad. So whatever the value of voltage is there, that I am taking as a common voltage and applying KCL over this. So I can apply KCL to figure 4c. So it becomes VC minus 12 by 4, VC by 2, and you have zero point 0.2 multiplied with dV by dt, which is equal to 0. I hope you understood how we frame this equation. Just simplify this equation as 0.2 dVc by dt plus Vc I am taking outside 1 by 4, and here you have 1 by 2, so 1 by 2, and you have 12 by 4 which has taken on to the right side, 12 by 4, it becomes 3, and you have here 0.2, so divide Vc by 0.2 and 3 by 0.2, and then you are going to obtain the value as dVc by dt plus 3.75 Vc is equal to 50. Now this is once again, it's a form of non-homogeneous equation. So this non-homogeneous equation has general solution, which is v of t is equal to minus e to the power of minus 3.75 t integral q value is 15 e to the power of p value is 3.75 t dt plus k e to the power of minus p value is minus 3.75 t. Simplify this value, we will get the value as 4. How we get 4? 15 divided by 3.75, you get the value as 4. And you have k as it is remained e to the power of minus 3.75 t. Now I can easily obtain the value of k from the initial conditions. We have the value of voltage across the capacitor, which is developed as 12 volts. So substitute 12 instead of Vc of 0. So that is 12, and it is equal to 4 plus k to the power of k into e to the power of 0, which is 1 here. So k becomes 12 minus 4, 8. Hence substitute the value of k in this equation, so it will become 4 plus 8 e to the power of minus 3.70. So this is how we solve this kind of problems. So the last two problems we have seen the rate, that is we have approached the solution at a faster rate. Why? Because we have strong information of the capacitor behavior, initial conditions and final conditions, and that is how we approach to the solution at a faster rate. If at all you have any doubts, please comment in the chat box. I hope you like this video. Please like and subscribe among your friends, and please press the bell icon for the future notifications.